Assalamualaikum. We are from Group 5 and will presenting our project assessment. This is our group members. Introduction. This project focus on estimating the parameter of the leg at Taman Tasik Section 7 Shah Alam. Since the leg has an irregular shape, it is difficult to measure accurately using traditional method. Therefore, we apply the least square method to fit a mathematical curve based on collected coordinate points along the leg boundary. Then, numerical integration was used to estimate the leg parameter. This study shows how numerical method can help solve real-world problems more accurately and efficiently. Next, our problem statement focus on the irregular boundary of Taman Tasik Section 7. Because the ledge shape is not regular, it's difficult to measure the parameter accurately using traditional method. Therefore, we use the least square method to fit the collected coordinates points into a mathematical model. After that, numerical integration is applied to estimate the parameter more accurately and efficiently.
Based on the problem statement discussed earlier, the objectives of this study are to measure the perimeter of a skewed shape manually using a string-based method. Second objective is to collect coordinate points along the shape boundary for data analysis. And the third objective focus on to apply the discrete least square method to fit a best fit curve to the boundary points. Another objective is to compute the perimeter using the arc length formula on the fitted curve. Last one, we compare the calculated perimeter with the manual measurement to evaluate accuracy. Next, the following section discusses the scope and limitations of this research. This study used the discrete least square method to approximate curves from sampled boundary points. Polynomial functions are used to model the shape of a skewed object. Accuracy is evaluated using error measures such as mean squared error. Assumes no error in input data, only output errors are considered. Limited to polynomial curve fitting, does not include trigonometric or spline methods. The performance may decrease with noisy or unevenly spaced data without pre-processing. High-degree polynomials may cause numerical instability and are not designed for large datasets or real-time applications requiring advanced methods.
For the implementation, this is the map diagram of the Sha'ala Session Control Lake Garden, and we plot it into the graph paper, and this is the plot coordinate, which is the scale of 1 cm to 75 meter. So, to determine the perimeter of the lake, we will divide the graph for region, and we will use the least square method, which is the polynomial of degree of 2, and which is the general function will be fx equals to a0 plus a1x plus a2x squared. And to solve it, we use the normal equation in matrix form, which is the number of points, which is n equals to 4. And after we obtain a0, a1, and a2 values and the function, we can use the arc-length formula to get the length for each region. And then we can total out the region length to determine the perimeter of the length. So the software used here is the Excel and Maple. So for the region A, we will get the first 4 points, and this is the x and y coordinates, and this is the notation for the normal form in the matrix 3 by 3. And after we get the coefficient, this is the function of the least square method of the polynomial of degree of 2, and the length for the region A is 5.5904 centimeters. Same goes to another region. So the total length will be 50.3538 centimeter. And if we compare to real scale, which is we need to multiply the total arc length with the 75, the arc length in the real life will be 1151.533 meter. And the actual length we get from the internet is actually 1184.4 meter. So we need to calculate the error of how much actually from the actual length. So the error we did it and we will got around 2.77%.
Okay, for the result and discussion, according to the CAPS maps, the online measuring tool that we use for this project, we can the approximate actual length of the section 7 is 1184.4 meters. As the result of calculation, we get 1162.245 meters. Then the force value are compared by determining error and again 1.87%, which is accurate. For the discussion part, the irregular shape of the left bank, the modeling process more challenging. Despite the error, the least square method still provide a reasonable approximation of the lab perimeter. So the accuracy of the project can be improved by using more coordinate points, maybe increasing the number of sections or applying more precise detail mapping tool. As the conclusion, the least square method and the outline are successfully used to estimate the perimeter of Tasik section 7. Then the difference may be caused by limited coordinate points, regression approximation, maybe irregular like boundary and scale conversion error. So overall, this project shows the least square method can be applied effectively to model real world shapes and estimate curve distance using mathematics.